So now I need to describe to you the fancier rule, which is known as Simpson's rule. And so this is, if you like, method 3. The idea is, again, to divide things into chunks. But now it always needs n to be even. In other words, we're going to deal not with just one box. We're going to deal with pairs of boxes. Here's delta x, and here's delta x again. And we're going to study the area of this piece here. So let me focus just on that part. Now let's reproduce it over here. And here's the delta x, here's delta x. And of course, there are various heights. This starts out at y0, this is y2, and this middle segment is y1. All right. Now, the approximating curve that we're going to use is a parabola. That is, we're going to fit a parabola through these 3 points. And then we're going to use that as the approximating area. Now, it doesn't look like, this looks like it misses. But actually, most functions mostly wiggle either one way or the other. They don't switch. They don't have inflection points. So this is a lousy at this scale, but when we get to a smaller scale, this becomes really fantastic as an approximation. Now, I need to tell you what the arithmetic is. And in order to save time, it's on your problem set what the actual formula is. But I'm going to tell you how to think about it. I want you to think about it as follows. So the area under the parabola is going to be a base times some kind of average height. And the base here, you can already see, it's 2 delta x. The base is 2 delta x. Now, the average height is weird. You have to work out what it is for a parabola depending on those 3 numbers, y0, y1, and y2. And it turns out to be the following formula. It has to be an average, but it's an interesting weighted average. So this was the punchline, if you like, is that there are such things as interesting weighted average. This one's very simple. It just involves 3 numbers, but it's still interesting. It's the following. It turns out to be y0 plus 4y1 plus y2 divided by 6. Y divided by 6, well, it's supposed to be an average. All right? So the total is 1 plus 4 plus 1 of these things, and 6 is in the denominator. All right, so it emphasizes the middle more than the sides. And that's what happens with a parabola. All right, so this is a computation which is on your homework. And now we can put this together for the full Simpson's rule formula, which I'll put up over here. We have here 2 delta x, and we divide by 6. And then we have y0 plus 4y1 plus y2 divided by 6 plus, that's the first chunk. Now the second chunk, maybe I'll just put it in here, starts, this is x2, this is x0, and it goes all the way to x4. So x2, x3, x4. So the next one involves the indices 2, 3, and 4. So this is y2 plus 4, y3 plus y4 divided by 6. Oh, no. I think I'll get rid of these 6s. I have too many 6s. All right. Let's get rid of them here. Let's take them out, put them out here. All right? Thank you. All the way to the end, which is yn minus 2 plus 2yn minus 1. Plus 4yn minus 1 plus yn. I was about to divide by 6, but you saved me. All right. So here are all the chunks. Now, what does this pattern come out to be? This comes out to be the following. This is 1, 4, 1 added to 1, 4, 1 added to 1, 4, 1. You add them up. You get 1, 4, and then there's a repeat. So you get a 2, and a 4, and a 2, and a 4, and a 1. So the pattern is that it starts out with 1s on the far ends, and then 4s next in, and then it alternates 2s and 4s in between. All right? So the full pattern of Simpson's rule is delta x divided by 3. I have now succeeded in canceling this 2 with this 6 and getting out that factor of 2. And then here I have y0 plus 4y1 plus 2y2 plus 4y3 plus, it keeps on going and keeps on going and keeps on going. And in the end, it's 2yn minus 2 plus 4yn minus 1 plus yn. So again, 1 and a 4 to start, 1 and a 4 and a 1 to end, and then alternating 2s and 4s in the middle. And this weird weighted average is way better, as I will show you next time.